Factors affecting the pressure in a liquid or pressure exerted by the liquid. The pressure exerted by the liquid, number one, depends on the density of the liquid. Example, you have two containers which are filled with different types of liquids but at the same depth. The depth is same for liquids. It's example 2 meter here. This one is also 2 meter. Density of the density of the liquid which is present here. Example, it is 850 kilogram per meter cube. And density of the second liquid is 1000 kilogram per meter cube. Which liquid is applying more pressure at the base, A or B? Which liquid is applying greater pressure at the base, A or B? So how to calculate this? The pressure exerted by the liquid is equals to density of a liquid multiplied by gravity multiplied by depth. They both have the same depth, so depth is constant. They both have the same gravity because it's on Earth, same planet, so gravity will be same. So how to calculate how to compare, you can see the pressure and density of a liquid are directly proportional. So if the one which is having high density, when we say a liquid is having high density, it means it will have more particles in a unit volume. When a liquid is having a low density, it means it is having few particles or small number of particles in a unit volume. So when we compare the pressure exerted by A with pressure exerted by B, so B will exert higher pressure as compared to that of A. And you can calculate this. How to calculate this? Pressure exerted by the liquid depends on density into gravity into height. So density here is 850, gravity is 2, multiplied by height or the depth. Sorry, gravity is 10, multiplied by height, which is 2. So 850 multiplied by 10 multiplied by 2. So you will get 17,000 Pascal. So pressure exerted by liquid A is 17,000 Pascal. What about pressure exerted by B? So pressure exerted by B is equals to density, which is 1000 multiplied by gravity, it's 10, multiplied by depth, which is equals to 2. So when you multiply all these factors, this will be 20,000 Pascal. So liquid B is applying more pressure as compared to liquid A. So pressure exerted by the liquid, number one, which factor depends? It depends on density of the liquid. Higher or liquids which are having greater density or higher density will apply more pressure on the base. And the second factor, it also depends on the depth. So how the depth affects the pressure exerted by the liquid? Example, you have two containers which are filled with same type of liquid but at different depths. So when you compare the pressure, because it's made up of or consists of same kind of liquid but at different depths. So because of higher depth, greater depth, there are more particles above. So as there are more particles above, they will apply high pressure. But smaller depth, less particles are above, so they will apply less pressure. So A will apply more pressure, B will apply small or less pressure. So pressure exerted by the liquid depends on the density of the liquid. It depends on the depth of the liquid. Is it clear? The pressure exerted by the liquid does not depend on the size of the container or shape of the container. Example, if we have 3 different types of containers which are filled with the same type of liquid. It consists of same type of a liquid. Their depth is also same. Depth of liquid inside the container is also same. So when you compare the pressure for A, B, and C, this depth is 2 meter, this depth is also 2 meter, this depth is also 2 meter. The density of the liquid which you are using is 1000 kilogram per meter cube. Density of liquid B is also 1000 kilogram per meter cube. And density of C is also 1000 kilogram per meter cube. When you compare the pressure with A, B, and C, what you can conclude about this? Which pressure is higher? Which will exert a higher pressure, A, B, or C? So when you compare these pressures, so basically when you compare the pressure exerted by the liquid, the question is compare the pressure exerted by the liquid, not the container, the flask. So when you compare the pressure exerted by the liquid A, B, and C, so in practical, they will apply the same pressure. How they will apply the same pressure? The pressure applied by A or pressure applied by liquid present in container A is same as pressure applied by liquid in pressure B. But how it apply the pressure, when we calculate the pressure, pressure is force acting on a unit area for a liquid. On which factor the pressure depends? It depends on density, gravity, and depth. So when you compare the number of, if I say there is 0.1, there is 0.2 and 0.3. Because this is the same type of liquid, so above 0.1, example 1, 2, 3, 4, 5, and 6 particles are there. Above 0.2, it will also have 6 particles. Above point C, it will also have 6 particles, because I mentioned that's the same kind of a liquid. Each liquid is having a same density, which is 1000 kilogram per meter cube. So there are same number of particles above A, there are same number of particles above B, and same number of particles above C. So if they have the same number of particles, So they will experience or exert same force on a unit area. So if the force on a unit area is same, the pressure will be same. And when you calculate the pressure, how to calculate the pressure? The formula: pressure exerted by the liquid is equals to density of a liquid multiplied by gravity multiplied by depth. So when I calculate the pressure of A, so density of a liquid is 1000, gravity it's 10, and the depth is equals to 2. So 10,000, 1000, sorry, density is 1000, gravity is 10, multiplied by 2. So it will give 20,000 Pascal. So pressure exerted by A is equals to 20,000 Pascal. What is the pressure exerted by B? It's also 1000 multiplied by 10 multiplied by 2. So when you multiply all these factors, again you will get 20,000 Pascal. And when you calculate for C, that's 1000 multiplied by 2 multiplied by 10. Again, you will get 20,000 Pascal. So what it shows, this calculation shows that the pressure exerted by the liquid does not depend on the size or the type of the container. It depends on the depth and the density of the liquid. So you may have a small container or a large container, but the pressure exerted by the liquid does not depend on the shape or the size of the container. So if we
Sir,
say, yes,
can you just go back to the previous slide where you drew the containers?
this one,
Yes, sir.
yes,
Sir, if I just, enclose these sides, the volume, and if I just enclose the sides, the container becomes, and I make the container in this shape, just as this container, the volume of this liquid will rise, won't it, sir?
the height, the depth will increase, yes.
So doesn't that make the pressure more?
That will change the pressure. But in this example, the depth is same for each. There are different types of container, but I took the same depth.
It's like this container B has a greater surface area at the top.
Yes, and at the bottom
In
it is.
the
But the idea is that the pressure exerted by the liquid does not depend on the size or the shape of the container. It depends on what is the depth of the liquid inside the container and what is the density of the liquid which we use inside the container. It
Sir,
does not.
actually,
Yes.
I didn't understand this really well. This part, how
Which
why shape doesn't alter pressure.
Why shape does not alter? Because liquid apply pressure in all the directions. So example, if I take this container and here is an object inside, okay, say a point A is there inside, and these are the liquid particles. So how this point will experience a pressure? How this point will experience a pressure? This point will experience a pressure because all the particles are pushing down. So they apply a force on this point, and this point will experience a force, and force divided by area. This point will experience a pressure. So if you have a container, if you have another container which is filled with the same type of a liquid and same depth. So 1, 2, 3, 4, 5, and 6. So what happened? Now you have the same number of the particle. If I take another point, so what will happen? They will also push this downward, and force divided by area. What they will create? They will create a pressure. Because they have the same number of particles above them, so the number of the particles are same means they will apply the same force. If they are applying the same force on a specific area, it means they will create a same pressure. So size of the container, the volume of the liquid inside the container does not affect the pressure exerted by the liquid. The question is pressure exerted by the liquid.
Sir, I'm not talking about that. I'm talking about like the depth. like if I, for example, compress the sides and I just,
if you change
make
the
it
look, for example, you're saying originally it was like this, and you changed like this. That was your
yes, sir,
question.
I compress this container and the volume of the liquid rises up.
Volume
And
of
that,
look, volume of liquid will be same. The only the depth will change. Volume of liquid will not change because you did not add the liquid. Volume is area multiplied by height. So what you did, the volume is constant. Like example, if originally I'm taking a 10 centimeter cube, if I'm taking a
yes,
10
sir, it's like
centimeter
if
cube,
you increase the depth, the pressure also rises, doesn't it?
yeah,
Like the
pressure
depth.
in that case, it will rise. But the point is that if you have different types of container which have the same depths or depth of a liquid is same, then the pressure exerted by the liquid will also be same. That was the point. Like example, what you're saying I change or you compress this container. So you, as you compress this container, what happened? You decrease the area, so the level of the liquid will rise. As the level of the liquid will rise, so as you can see, now there will be more particles above point A. So what will happen? There will be high or increased pressure. So pressure exerted by the liquid, if we have the same depth of a liquid inside the container, so pressure exerted does not depend on the shape or the size of a container. That was the meaning.
Sir, sorry, can you just say that again? It's really hard to
Look,
comprehend.
if I have different containers which have same depths of the liquid, so different container with the same depth of the liquid, in that case, I did not say all have the same volume. I did not use that word at all. Did I say they have the same volume? I did not mention they
Like
have the same.
I'm saying the depth, sir. It's really
Yeah.
confusing.
So depth here, look how many particles. Example, it has 4 particles above it. This contains different amount of liquid. The volume of liquid might be different, but the depth is same here. So if the depth is same, they will have the same pressure. Here also, if the depth is same, it will apply the same pressure because same number of the particles above the base. You're not taking the full base. I'm taking a point. At that point, pressure exerted by the liquid at a point on the base will be same. But if you have a container example, you have 2 containers with different amount of liquid. Which one you think will apply more pressure at the base, A or B? Yeah, which one you think will apply more pressure?
It's B.
It's B. Why it's B? Because you can see here, B will have greater number of particles above, and A will have small number of particles above. So what it shows that the pressure exerted by the liquid depends on the depth of the liquid which is present in the container rather than the shape or the size of the container. Is it clear? You can simply apply a formula. Yes, you can apply that formula as well. Yes, Afif.
It's somewhat clear, sir.
No, it should not be somewhat. It should be clear from the idea. I think the why you're confused because you're considering that all containers have the same volume. Maybe you're confused in that sense that all containers have the same volume of the liquid. It's not like all containers have the same volume. They have different volume of the liquid inside, but the depth of a liquid is same for inside each container. So if depth is same, then the pressure will be same.
But the pressure also depends on volume.
Pressure does not depend on the volume. Pressure exerted by the liquid depends on the density of the liquid, depend on the gravity of the liquid, and depends on the depth. Does not depend on the volume. Pressure exerted by the liquid does not depend on the volume of a liquid. It depends on the depth of the liquid, and it depends on the density of a liquid. So if you have, example, a bucket and you have a container with a small area, you put the same volume of liquid. I put 10 cm cube here and I put 10 cm cube in container B. Example, the area here is 5 centimeters square and area here is 2 centimeters square. This is the volume. This one is a base area. This is the volume. This one is a base area. What will be the depth of the liquid here? So as we know, volume is equals to area multiplied by depth. The volume is 10. Area of the base area is 5. So what will be the depth of the liquid? So it will be 10 divided by 5. So depth is equals to 2 centimeter. So this will have to, the volume is same, but it will have a depth of 2 centimeter or height of the liquid from bottom to the top surface, it's 2 centimeter. Then you transfer the same amount of liquid into another container. When you transfer the same amount of liquid into another container, what will be the depth? So volume is area multiplied by height. So volume is equals to 10, area is equals to 2, and height is h. So 10 divided by 2, that's equal to 5 centimeter. So when you transfer the same amount of liquid here, so the depth will be 5 centimeter. Now, my question is, which case the liquid will apply more pressure at the base of the container? The pressure exerted by the liquid. Which case the liquid will apply greater pressure? The same type of liquid, A or B? A or B? Which case the liquid will apply more pressure at the base? So in case of B, it will apply more pressure. Why? Because there are more particles. There are more particles above the surface, so they will apply more pressure. Few particles above the surface, so apply less pressure. So pressure exerted by the liquid depends on the depth of the liquid. If it's deeper, it will apply more pressure. That's why, like example, for a deep sea diving, as the divers, they're using a high pressure helium and oxygen, because as we go down or deep inside the water, the pressure exerted by the liquid will increase.
Sir, like you were trying to say that the pressure of the liquid does not depend on the shape.
Pressure exerted by the liquid. Yes, that's the point.
That's the point. So even if I change containers, the liquid will have the same depth. I will have the same amount of particles.
If the liquid, if two liquids, if we have two different containers and they have the same depth of the liquid, then the pressure exerted by the liquid does not depend on the shape of the container.
But like, shouldn't those containers have the same base areas as well so that they can exert the same pressure?
No, you're mixing the pressure exerted by the container with pressure exerted by the liquid. We are talking about pressure exerted by the liquid, not by the container. These container, the pressure exerted by the container is what? It's force divided by area. So force or the weight of the container divided by area of a container, that's a pressure exerted by the container. But I am saying the pressure exerted by the liquid. So pressure exerted by the liquid, if you have different containers with different base areas, the pressure exerted by the liquid depends on the depth of the liquid rather than the surface or the shape of the container. If they have the same depth of the liquid, they will apply the same pressure. That's the main point.
Okay, sir. Thank you very much. I get it now. Sorry for all the trouble.
No problem. It's okay. You have right to ask a question. More question you ask, it will clear your doubts. It's okay. I don't have any issue. It's better you ask question. So if you want to calculate, yes, I will give more examples. So if you want to calculate the pressure exerted by the liquid or pressure exerted in the liquid. So example, there's a storage tank. A rectangular storage tank is filled with a paraffin at a depth of 0.8 meters. So the depth of a liquid is 0.8. The density of the paraffin is 800 kilogram per meter cube. Calculate the pressure at the bottom. So how to calculate the pressure? Pressure exerted by the liquid depends on the density of a liquid, gravity, and depth. So density of a paraffin is given 800, the gravity is 10, and the depth of a liquid which is there in the container is 0.8. So when you multiply all these factors, you will get 6,400 Pascal. So in this example, 4 different liquids are poured into 4 containers. The diagram shows the depth and the density of liquid in each container. In which container is the pressure on its base is the greatest? So pressure exerted by the liquid. So how to calculate this? So pressure exerted, its density into gravity into height. So density is 3.1 multiplied by gravity is 10 multiplied by height. For all the cases, the gravity is 10, so I don't have to multiply with gravity just to know which is the highest number. So 3.1 multiplied by 10, so I'll get 31. 1.2 multiplied by 20, so I will get 2.4, just 24. 1.3 multiplied by 30, so 39. And 0.8 multiplied by 4, so it will be 24. Sorry, 32. So which is exerting the highest pressure? C is exerting the highest pressure. Four identical beakers are filled with equal volume of a liquid P or Q. Liquid P is more dense than liquid Q. At which point least pressure, smallest pressure. So first thing, liquid P is more dense than liquid. So P will apply more pressure, so it should be Q. And then you check the depth. So here, D is the right answer. Why? Because we need a least pressure. The one which will apply the smallest amount of pressure. You can check the number of the particles. It's high density, so that it will have more particles above it comparatively. The pressure exerted by the liquid it is the depth of the point inside the liquid. So when you compare, you need a least pressure. Least pressure, the one which apply the smallest amount of pressure. So A, when you check A, C, B, and D. First thing, it should be low density because the pressure exerted by the liquid depends on the density, depend on the depth, depend on depth means the distance from the surface of the water. Not from the bottom, it's from the top. So it's from the surface of the water, you measure a distance, that is the depth. So pressure is density into depth into gravity. You want a least pressure. Least pressure means the one which, so it should have a low density and it should have a least smallest depth. Yes, Tausif, you're right. The water also exert upward force, and that upward force is called upthrust. The upward force is refers to upthrust. So in this case, we need a least pressure. So they mentioned liquid P is more dense than liquid Q. So this is having high density and this one is having low density. So what happened? The particles which are at the bottom, they try to push it up, and the particles which are at the top, they try to push it down. So there are more particles which are at the bottom, so the pressure will decrease. So as the depth, the pressure and depth are interrelated. If smaller depth means less pressure exerted by the liquid. Is it clear? You have a student placed 4 identical beakers on the bench. 2 beakers contain a salt water of a density 1.1 gram per centimeter cube, and 2 beakers contain a pure water of a density 1 gram per centimeter cube. Which beaker exert the greatest pressure on the bench? So first you have to check the density, and then you have to check the depth. So in this case, this is a salt water. The density of a salt water is 1.1 gram per centimeter cube. So it's having high density. So either A can be answer or B. And then when you check the depth, and you can also solve this question in terms of base as well, because in the question, if you check the question, they mention which beaker exert the pressure on the bench. So they're asking for pressure exerted by the beaker on the bench. So to calculate this, what we can use pressure is force divided by area. All are identical beakers, as they mention identical beakers, so they all have the same areas. Which beaker contain greater amount of liquid or greater weight of the liquid? So beaker A contain greater weight of the liquid. So if there is more weight, it will apply more pressure on the bench. This is about the pressure exerted by the container, not about the liquid. But even in this case, pressure exerted by the liquid is also greater. Question 17. The diagram shows three containers, J, K, and L. Each container contains water of same depth. Which statement about the pressure of the water on the base of each container is correct? Pressure exerted by the water. So the pressure exerted by the liquid or pressure exerted by the water, it does not dimension. Each container is filled with the water and it's of same depth. So they all will apply the same pressure. The water pressure in this is same in all three containers. The diagram shows four divers at the bottom of four different swimming pools. Two swimming pools contain fresh water and two contain a salt water. Fresh water is less dense as compared to salt water. Which divers feel the least pressure from the water? Which diver will feel the least pressure from the water? So A is the right answer. It will experience the least pressure because of smaller depth. Because they asked for least pressure, salty water is having a high density. So salty water will contain more particles above the diver. That's why experience greater pressure in salty water as compared to, the question was least pressure, not highest pressure. Is it clear the concept of the pressure exerted by the liquid? So if we want to calculate the pressure here, an archaeologist is investigating a shipwreck and discovers a wooden box on the seabed. The dimension of the lid of the box is 1.2 by 0.8. The pressure of the atmosphere is 1 exponent 5 Pascal. The lid is 15 meter below the surface of the sea. The pressure on the lid due to seawater. So what is the pressure due to seawater? So to calculate this pressure, it's equal to density multiplied by gravity multiplied by depth. So density of the seawater is 1020, gravity is 10, and the depth is 15. So 1020 multiplied by 10 multiplied by 15, we will get the pressure exerted by the seawater at the depth of the, so 153,000 Pascal. I'll share another link.